We are now looking at passage 3 from ACT 70A. This passage deals with a capacitor and a battery that is set in the capacitor, and there are two various studies. In study 1, we see that the battery is being charged, and in study 2, it is being discharged. Question 14 reads, between a time of 0 seconds and a time of 30 seconds in study 1, the voltage across the capacitor blanks. Now again, with these science passages, it's important to always look for these clues. Right here it says study 1. That's telling you exactly where you can go to find that answer. So let's go back to study 1. And when we do go to study 1, we see that from 0 to 40 seconds, that charge increases. So that being said, F, it increases only. Question 15 reads, based on table 2, starting at a time of 0 seconds, it most likely took how long for the charge on the capacitor to equal 200 PC in study 2? Again, using the clues, we're going to go to table 2, study 2. Now, in table 2, you'll notice that a charge of 200 PCs isn't directly given to us, but we do see 150, and we also see 240. So we can say that it's going to probably fall somewhere in between there. So somewhere between the 5 and the 10 seconds. Going back to your possible answers, you'll notice that B gives us exactly that, between 5 and 10 seconds. Alright, we're rolling. 16 says, suppose that in study 1, the voltage of the battery had been 10 volts instead of 4 volts. Based on figure 2, once the capacitor was fully charged, the voltage across the capacitor would have been blank. So again, 10 volts instead of the 4 volts, and we're going to be looking at figure 2. Now it's important to remember that the battery was 4 volts, right? And if we look at figure 2, we'll see that the charge maxed out at 4 volts. So it's safe to say that if now we have a battery that's 10 volts, it's probably going to be fully charged at 10 volts. Number 17 reads, which of the following statements best explains the value of Q at a time of 0 seconds in study 1? At a time of 0 seconds, the blank. Well, we know that we're looking at study 1, but you might be asking yourself, what's Q? If we jump back, we could see that it explained to us that Q equals charge. Now, when we look at table 1, we'll see that at a time of 0 seconds, our Q was 0. Now this one's a little trickier because it didn't tell you exactly to go to table 1 like some of the other ones did. However, by following some of the clues, like it told us we were going to be looking somewhere in study 1, and it told us that we're going to be looking at the value Q, we could go back and see that Q was touched on in table 1, which would help us get to the answer of A, saying that the capacitor was uncharged. Number 18. Based on table 1, and figure 2, as the capacitor was being discharged, now that's the key right there, it's being discharged between a time of 0 seconds and a time of 30 seconds, in study 2, the voltage across the capacitor would, now if we go back and we look at study 2, we see that as we discharge the battery, the charge dropped. So it's safe to say that it would be G. It decreased only. Number 19. Which of the following statements best explains the value of I at a time of 100 seconds in figure 4? At time 100 seconds, the blank. Now again, clues, we're going to be looking directly at figure 4. A time of 100 seconds, you have to figure out what I is. Now up here it explained to us that I is the electrical current. So if we look at a figure 4 over here, we see electrical current based on time. If we go down to 100 seconds, we could see that electrical current is at 0. So it's safe to say that the capacitor was fully discharged.